Welcome everybody to this month's Third Thursday. My name is David Stevens, also known as Laser Dave. And today we have a great new seminar, brand new content for engineering materials. It's going to be a little bit longer seminar, but if you definitely have any questions, please feel free to answer or ask those questions as we go through this course. This course is going to cover a lot of engineering type materials that are laser friendly. What that means is there's a lot of materials out there, of course, but this course is going to kind of focus on some of the more common laser-friendly materials that are specific more for operating with your laser, known good materials that are also known engineering-based materials. So we're going to go ahead and move forward here. It is a longer seminar, and so if you have any questions, this seminar will also be recorded so that you can have access to it online at a later date should you want to come back if you need to. So let's go ahead and move forward here and get going. Okay, engineering materials. This material application, of course, just like any others, if you've joined me before, I use a lot of QR code links. This is a quick and easy method in order for you to get access to web links, files, videos, downloads, things like that. If you're not familiar with using QR codes on your phone, it's pretty common these days. Just open your camera app. Point it at the QR code, but don't take a photo, and a link will show up on your mobile device's screen. Touch that link to have access to these types of web links, files, and videos that you may want to reference to at a later date. Trotec also is a very social company. If you are interested in following along with current trends, trainings, products, applications, materials, please go ahead and scan your favorite social media platforms QR code here. And this way you'll be kept up to date with these current trends, any future trainings, and basically any type of event or device or product that we produce is going to be posted on these different popular social media platforms. Okay, the course outline today is going to cover these materials. These are materials that are, like I say, very laser friendly. There are a lot of different materials out there, and so I kind of go through and select the most common based on questions that I've received over 21 years of doing this. Also materials that tend to be very popular with engineering-based type applications and materials or products in combination with also being laser friendly. Today's course is going to include stainless steel, polycarbonate, polystyrene, Trolleys Textures, Polyurethane Foam, ceramic, elastomers and rubbers, and then we're going to follow it with a secure Tessa laser tape, which is a very industrial tamper-proof type tape, which I'll cover as well. Again, if you have any questions whatsoever during this course, please post them on the side, and then we'll go ahead and cover that. I have Andy Wellens, our industrial sales manager, that will be joining me at the end of the course, and he and I will then answer any of those technical questions on materials, applications, maybe questions you have on the product, basically anything you can think of. Now, we are going to be covering a couple different platform of laser types today. Just for those that may not be familiar with the types out there, Trotec makes two types of motion system within our product line, if you will. We make a Galvo base laser system, and we make a gantry-based laser system, or also known as a flatbed. The flatbed is a large working area, XY axis gantry motion system, typically allows for a much larger working area. It has less focal tolerance than a Galvo, but motion system is very robust, but it allows a lot of configurations, accessories, upgrades, and it ranges in much, much larger sizes. We can range in much, much larger sizes because the head or the laser beam is directed by a gantry motion system. Now, we also have a galvanometer. Galvanometer delivery system is one fixed point above the surface of the product. Usually it's a much smaller working area. Common ranges between 2.7 to 12.2 inches. But then we also can move that gantry or the Galvo system, kind of like the gantry, along a motion system to make it larger. These two motion systems are the primary two that we manufacture. And so that's what I'm going to cover today. There are a lot of different type of processes we're going to cover, which I will be referencing to today. So just to make sure that everyone's on the same page, I'm going to cover a few of the different terms that are common in the laser industry. Laser engraving is the process of vaporizing some of the base of the material, producing a cone-shaped indentation. So when you're engraving into plastic, rubber, or even materials like wood, the laser actually produces depth into the surface. This is considered a laser engraving. Laser marking is the process to where we're not actually producing any depth. So the laser is actually disturbing the surface enough to produce contrast, but it doesn't actually produce any discernible depth. Materials like coated metals, engravers, plastic, different types of materials like this will actually produce a high contrast mark, but there will be no discernible depth into the surface of the material. Now, laser cutting, pretty obvious on that one, using the lasers to penetrate all the way through the material. Typically, the material needs to be a combustible-based material in order to be cut. There are a few exceptions of that, which we will cover, but of course, that is penetrating all the way through the material until the material is cut out. And then the last one I wanted to cover, which we'll be covering today, is laser fusing. Fusing is kind of like the process of welding, where you're adding an additional material to the surface of another material. So we're actually fusing a type of metal or material onto the surface of a metal, for example, such as the Surmark laser bond Thermark material over bare metal, which we'll cover as well today. Now, I do want to cover a few materials that are engineering-based materials that are also not laser-friendly. Not even because that it don't work, but it's dangerous for your laser system. So this is our list of materials to avoid with your laser system. The reason is because these materials can produce chlorine gases, and these chlorine gases can be corrosive. It's not that they don't work with the laser system. Actually, a lot of them, like the polyvinyl chloride, PVC type materials, work exceptionally well with lasers. However, their outgassing produces chloride. And that chloride produces basically, it's in essence a vapor form of hydrochloric acid mixed with atmosphere or moisture in the atmosphere is actually going to cause your laser system to corrode. And so this is why some of these materials can be dangerous. Also, some of them can be dangerous just from their outgassing even after they take in the machine or after the product is taken or material is taken out of the machine after it's laser cut. So this is the list of kind of no-no with your laser system. Stay away from them, either for danger to your laser system or they are danger to you as a human. So stay away from these type of materials. Just for that reason alone. Other methods of processing with mechanical means are typically recommended. Okay, so we're now going to start into the course today with stainless steel. Stainless steel is an extremely popular material across the board because it is a material that is very, very useful in the fact that it doesn't tend to corrode like a lot of your metals. There's not a lot of corrosion due to the chromium that it has in the actual material. Typically, it's a steel-based product mixed with chromium in order to have corrosion, rust, and stain resistance. Today, some of the more common applications from the laser standpoint are barcoding, identification plates, traceability, serialization, gauges, surgical tools, signage, decoration, all of the above. Basically, the lasers give you the ability to put a permanent, durable, high-quality mark onto the surface of your product, your application, in this case. And instead of adding an additive like a paint or another process or an inkjet, it is a far more durable. And so especially when it comes to tooling or barcoding or serialization where you cannot have that image or that graphic be removed easily, it's going to allow for more of that traceability for long-term type wear, also being able to traceability within time. And that's where the laser comes in and why it is such an advantageous technology for processing materials like stainless steel. Now, to process stainless steel with your laser system, this can be done in a lot of different ways, and I'm going to cover all of them today. In order to process with the CO2 system using metal marking compounds, you need at least 30 watts. The more wattage you have on the CO2 side, the faster you're going to be processing this material. And I'm going to cover exactly how to process with these materials using the fusing process, as I mentioned earlier, shortly after this slide here. You can also process stainless steel, of course, with a fiber laser. And these are the two, besides the Galvo and the flatbed gantry-based motion system, we also have two different types of lasers, the CO2 and the fiber. Fiber laser is a much shorter waveform, and it marks directly into stainless steel and metals much, much better. And so I'm going to be discussing a lot today the difference between some materials work with both wavelengths, both types. Others work differently with a material. And this is a great example. Stainless steel cannot be directly marked with a CO2, but we can use metal marking compounds, where a fiber laser will mark stainless steel beautifully with any wattage without any compound, and it's a subsurface into the material mark. The surface fused mark with a CO2 laser using metal marking compounds are used with compounds like Surmark, Thermark, or Laser Bond. These are Surmark and Thermark laser bond type materials are in essence, they're a liquid-based ceramic type compound that, when exposed to the heat of the laser, creates a fusing effect and actually creates a glass that's melted to the surface of the metal, producing a fused mark. And we'll get into that a little bit more. Fiber lasers in turn will actually do a direct mark into the metal by actually removing the material itself, producing a direct mark or a subsurface engraved mark. Flatbed or Galvo laser engravings will both work with this. However, if you want depth into the surface of the metals, we're going to need a Galvo laser, and we'll cover that as well in this section. So the advantages, of course, with lasers when it comes to processing stainless steel is that it's a permanent, durable mark. It cannot be removed easily because you are physically going onto the surface of the metal, unlike materials like paints and inks and stuff like that. They can't be taken off with chemical. So that durability is going to give you a higher perceived value. It's a long-lasting material, UV stable material. That is the true benefit of laser processing with a stainless steel. Now, there are some limitations. It is more time consuming because it is such a dense material. This it requires a little tip more laser power or more time in order to process, especially if you want a little bit depth or more depth into the surface. It's also extremely difficult to cut. I don't recommend cutting stainless steel with a CO2 or fiber. I have had some success with shim stock type thicknesses up to 1 to 3/1000ths of an inch foil thicknesses stainless steel, but it is not a very viable application for cutting metals. And so we don't really recommend that. And our systems aren't really designed for cutting, especially anything thicker than a foil thickness. So that is definitely a limitation for stainless steel. Mechanical means are a much more efficient method. And then, of course, the other limitation is a heavy material tends to be a little more expensive as well. Now, we make both a Galvo and then, of course, the flatbed machine, but we also make what's called the Trotec Flex. The Flex machine is ideal for stainless steel because it integrates both CO2 and the fiber into one machine. This machine is kind of the best of both worlds when you want to be able to do the highest variety of materials on the planet, because it supports both CO2, which encompasses about, I would say, close to 80–85% of all materials on this planet, where the fiber laser will incorporate an additional 10 to 12%, giving you the majority of all materials out there. And so this combination of the Flex unit that allows the two laser sources to be activated alternatively at one job, or they can be done independently, allows you the diversity of materials. And especially something like stainless steel, you can do a fused effect with the CO2, or you can do a fiber mark with the fiber laser all on one machine because there's two lasers on this one machine. Laser sources are easily assigned at the touch of a button in Job Control or our new Ruby software. So all you have to do is just tell it what color you want to use the CO2 based on a visual color on your screen, or another color you can assign as the fiber. In this way, the laser can jump back and forth pending you have the right lens assigned on the laser system. The Flex unit allows all CO2 laser applications, annealing, marking, and metal engraving, as well as the fiber laser as well onto it. Every Speedy is ready for flex. And so if you have a Speedy laser system and you want to add a fiber laser, you can do that. Where the Galvo laser system, which I mentioned earlier, basically has 2 mirrors, smaller working area, but it is 10 times faster than the flatbed gantry-based motion system. Class 4 laser unless enclosure isn't provided. This means that the laser class 4 means that the enclosure is actually provided around the motion system. You can get this system as both an open class 4 or a enclosed laser system as well. You can also integrate into production processes with the Galvo system. So this fiber or this laser wavelength or this laser platform can be integrated into a motion assembly line, a process line. It can be integrated in with robotics, basically any type of industrial type atmosphere. The Galvo system is nice for that. Rather than doing one-up type products, if you have a production type setup, especially on metal marking like stainless steel, this laser is the ideal solution for that. So let's get a little bit into some of the more common applications for this. As I've kind of mentioned a little bit, stainless steel marking with the metal marking compound is probably the most common on the flatbed systems. Metal marking compounds, including Surmark, and laser bonds, those are the top 3 materials out there, actually fuse to the surface of the metal, and you get a nice high quality black fused mark. This is not as durable as a fiber or a Galvo fiber laser because it is not subset or engraved into the metal. It is more of a melted glass fused surface onto the surface of the metal. The way the Surmark and laser bond works is this. You basically take raw stainless steel, and I have to indicate raw because the metal cannot have any type of clear coating on it. Clear coating meaning some type of clear paint, polyurethane, lacquer, varnish, or anything like that. It's got to be an actual raw metal. This process also works with any metal, as long as that metal is raw and there's no clear coating on it. So you take that raw metal, you spray it with the compound. Typically comes in spray cans. It comes in a paste that you can brush on. You can also buy it in a tape where you can basically like take a piece of tape and place it on the surface of the metal. Then you stick it into the laser. And then laser the material using preset settings for the metal marking compounds. Take it out of the laser system and then just take it and place it under your sink with water, and the excess material washes right off. It's a clay-based compound, molybdenum trioxide type sandy material, and so you can wash it right down to the drain safely. And then once you're finished, you're going to actually have that fused mark, and that finished fused mark is a high contrast. If you look under a microscope, it's actually looks like little beads of glass have been melted to the surface of the metal, and that's in essence what it is. So this is an extremely popular process. It doesn't require the additional cost of a fiber laser or a Galvo fiber laser. It is a great solution for those that don't want to not only spend the money but also just have the need once in a while to do a fused mark. The other drawback with this compound is it can be kind of expensive, especially if you're doing it a lot. I mean, these cans can range from $35 to $75 a can, or the paste can save you a little bit more money, but there is an additional revolving cost if you're doing this all the time. And that is the limiting factor. You may not pay upfront to buy, say, a fiber laser, but you will pay as needed for this compound should you want to do this process. Now, engraving stainless steel is with, for example, a fiber laser. CO2 laser will not engrave into stainless steel, so it will produce no real depth or real darkness into the surface of the metal. CO2 is primarily only works with the Surmark, Thermark, or laser bond compounds. Now, if you want to actually engrave instead of mark, then you would need a fiber laser, either a flatbed fiber laser or a Galvo fiber laser to mark the darkness into the surface of the metal, actually utilizing the carbonate in the metal to produce that contrast. Typically requires high power, slow speed, higher DPI. It is a time-consuming process. Here's an example of a fiber laser actually running the application. So this is a Galvo fiber laser actually marking into the surface of a piece of stainless steel. The nice thing about a Galvo system is we can hit it with more than one angle, and then we can produce a much higher contrast. And so that was a time-lapsed version of this, but it was an actual mark directly into the surface of the metal. This is a great process. Again, the Galvo is the ideal solution, especially if you want to produce any depth into it. Flatbed systems will not produce depth. I don't care how many passes you take. You may be able to see 1/1000th of an inch or so, maybe 2, but it's never ever going to be the same as a Galvo fiber. So if you do want depth like this, the Galvo fiber is ideal because not only does it produce a faster response to the laser, what it does is allows the laser to go in multiple angles as it's doing multiple passes, and in between each pass it does what's called a cleanup pass. And I have a tutorial here. If you are interested in this, you can scan this QR code and it'll explain from start to finish using our speed marker software all the way through our Galvo system how to create depth with a Galvo fiber laser. But the benefit is the fact that it can go multiple passes, and it can be 10, 20, 30, 40, 50 passes, depending on the depth that you want. So it can be time consuming, and the total time will depend on what wattage of laser you have. Just like CO2, fiber lasers have wattages ranging, all the way up. And so the higher your wattage you can afford, the faster, of course, it's going to produce depth. And here's an example of this small gear actually engraving with depth. And then this is live right here, and then I'm going to do a time lapse of multiple passes. I think I hit this one with 20 or 30 passes, and so that was one pass right there, and then we do a cleanup. And so as it turns white, that would be a cleanup pass, and that cleanup pass basically removes any of the excess debris, carbon, slag that is left over from each pass. Also, I changed the angle 15 to 20 degrees per pass, so we get a different angle per pass. And then as we go through after 20, this is probably 10, 20 minutes of engraving, we now have the finished result. And that is right out of the machine. I'll take a little Scotch-Brite pad to it. It cleans up nicely. And we now have that nice, beautiful, high contrast, really amount of depth into the surface of the metal. This is probably a little more extreme than most people need. Most applications only require up to maybe 3, 4, 5/1000ths of an inch depth for certifications. This one is pushing closer to 15 to 20/1000ths of an inch depth, just more for visual appeal. So that is the process. Galvo fiber lasers are ideal for producing depth. The higher wattage of fiber that you have, of course, the more time consuming or the less time consuming it would be. So besides, of course, marking with depth, we can mark into it to produce darkness, but we can also produce a mark onto the surface, which is an annealing process. So the fiber laser will produce depth into it where you actually produce a teeny bit of depth and you get a nice dark response. But I can also do what's called an annealing process, and this is a mark. A mark, as I explained earlier, is the process of producing contrast without producing any depth. And so what we do is we take the laser out of focus. This can be done on both the flatbed systems, like your Speedy series with a fiber laser, or the Galvo system. Both can do this process. The marking by annealing involves heating the surface of the metals just below the melting point. And what this does is it creates an oxide layer just below the surface. Once the carbon rises to the oxide layer, which will take some time, the result is a high contrast, very smooth mark that does not damage the surface of the material. This is especially ideal for like your surgical instruments where they can't have that surface be disturbed. It also tends to produce a much blacker looking black because you're pulling that carbon out. It is kind of reflective, and so if you've got a reflective surface of the material, angle can determine how much contrast is looked, but it does definitely produce that shiny, really high perceived value look into the surface of the metal with a very durable mark. It's not adding anything like the Surmark or Surmark or laser bond compounds. It's durable. It's going to be more sanitary because there's no actual damage to the surface of the metal, and so this is a great one or great application. Now to do this, it requires some technique, typically about a tenth of an inch out of focus, because the way this works is we take the beam out of focus away from the material slightly, and this is more on the flatbed. You also take it about the same on the Galvo system as well. And what this does is it broadens the beam out a little bit more to kind of allow more heat to be raised from the graphic rather than engraving. I don't want the beam to be super, super sharp. And when you take a laser beam away from out of focus, the beam becomes more dull or less sharp, if you will. And that actually produces more heat buildup in the material. And so by taking it out of focus, running it at high power, slow speed, and a high DPI, we're able to achieve the annealing process. Here's an example of the annealing process on a Galvo fiber laser. You'll see here, takes lots and lots and lots of passes, but you get this nice reflective metallic looking black that comes from it. This is time lapse. This is not real because just this file right here probably took about 3 or 4 minutes. So I do time lapse it in order to, kind of keep this video a little shorter for example purposes. I've taken a second pass at about 33-degree angle here. And then I'll do a second pass in this case with laser marking and cutting on the bottom. And so this is nice because what it does is it gives you that black effect onto the surface of the metal, again, without actually distorting or engraving into the surface of the material. Just note that it is 2 to 3 times more time consuming than engraving depth into the metal or a slight amount of depth or just engraving into the metal. And so because it takes so much higher DPI because you're drawing heat out. Different levels of stainless steel that have different levels of carbon in them will affect how long this takes. And so different types, your 302, your 304 stainless will effectively be different times in order to produce the annealing effect than different. My mind just dropped here. In order for the blackness to come out will depend on how much carbon is in the metal, and that'll be determined by what grade of stainless steel you're using. That's what I was trying to say. So beyond that, with the annealing effect, we can also do it in outstanding effect using what's called a Mopa fiber, and that is color on metal. So we're also annealing, but annealing is great because it typically will produce a black mark. Well, we also offer what's called a Mopa fiber laser. And a Mopa fiber laser is still a fiber laser, but it allows additional control steps. And these additional control steps will allow us to actually control the wavelength, the frequency, the speed. And when we control these, if you've ever taken a flame or torch over the surface of the metal, you may see it kind of turns bluish. Well, if you control the exact amount of heat at a location, we can actually achieve color, especially on materials like stainless steel. Now, a standard fiber laser will do this limitedly. You can get a few colors, but for more control, the Mopa laser in essence gives more control over a fiber laser and allows us to handle more colors. This isn't a very advanced trait and requires a lot of an understanding and skill set in order to do. It also heavily depends on the type of metal you're using, the grade of metal, even the manufacturer you're using for consistency. And so the way that this works is it draws the metal out. It works a lot like the annealing process. It looks just like the annealing process. But as you can see here, even at a 20x time lapse, it is a very slow process because not only are we drawing the color out like black or annealing, we're having to do it at a very, very localized frequency and heat spectrum in order to achieve the color we want. This is at an angle, so it's tough to tell, but as soon as I open up the machine and put it into the light, you're gonna start to see that color. So in this, of course, I was going for the Trotec red. It does take some time to kind of dial in that color. Consistency and everything have to be spot on. Everything from the material manufacturer to your laser needs to be straight on. So I don't promote this that often because it is a very advanced trait. But if you are producing a product, you want a color logo on it. It's something like a knife blade where you don't want to engrave down inside of it. This is a great alternative for doing that. And it is a very, very high perceived value because there's really no other way to do that, produce these different colors onto metals without the use of inks or any type of external type product. If you want to learn more about Mopa, I know I didn't get into it exactly what it is and how it works and stuff like that because it is a very advanced capability. I have a QR code. Feel free to just hold your phone up, scan this QR code, and it'll explain what the Mopa is and the real differences between that and a standard fiber laser. They're both fiber. Everything a Mopa is still going to do everything a standard fiber laser does, but just has more capabilities, more control, especially when producing more colors on metals, and it'll also make your aluminums brighter white. It'll bring out tends to do more darker colors on plastics and stuff like that. So a great alternative to a fiber laser, which just gives you, it's like a specialty fiber laser, if you will. Okay, stainless steel applications, as I kind of mentioned before, it's kind of the whole gamut. Engineering materials are probably the more popular, but it does, of course, get into everything from gift items to awards to anything. It's just a very, very popular material. But that ability to actually mark directly onto stainless steel with an extremely high contrast, durable mark cannot be done in any there's no better way to do that than a laser processing. If you are interested in getting more information on stainless steel, for example, where to get stainless steel, I got a couple resources for you. I tend to get it from McMaster Carr. They do just about any industrial material out there. You may be familiar with them. ID Plates is another great one if you're looking for pre-cut blank plates of stainless steel or other metals. You can scan this QR code. And then, of course, I've included the tutorial for deep metal marking here as well. So these are just some resources for you. If you ever want to come back to this course, scan these with your phone and do a little bit more investigation, or need the resources of where to get these materials, feel free to scan these codes. Okay, polycarbonate. Polycarbonate is it's a very, very common material because of its durability in the engineering plastics world. And unlike stainless steel, it is a polymer base and stuff versus a metallic. And so, but polycarbonate is ideal because it's so strong. It definitely has a lot of characteristics that a lot of plastics don't have. And there are a lot of different things that the laser systems do very well with this material. Polycarbonate is a tough, durable plastic that is much stronger than acrylic. It's lightweight, stable over wide temperature range, which is nice. It can handle the temperature because it has carbon in it. And that's the difference. It's a polymer that actually has carbon in it. And that carbon inside of it gives it a lot more strength characteristics and the ability to handle a lot higher temperature range than most plastics. It is slightly less transparent than acrylic. But it's more, and it's also more prone to scratching than acrylic. But it is easily worked, molded, and thermoformed type of plastic. And so you tend to see this plastic because of these characteristics in a lot of engineering-based products, components, or R&D type devices when used for some of these engineering applications. Some of the markets and applications for lasers that we have come across that have been very popular is the COVID-19 protections, desk shields, face shields. You'll see it in water bottles, police shields, sunglass lenses. It's commonly used in automotive, suitcases, airplane windows, where you need that transparency. I also noticed that a lot of in protective type coverings in for like engineering environments or manufacturing environments where you need to be able to look into a hazardous condition, but you need that shield so you can still see through it. And so the lasers are nice because we can cut it, we can engrave it, we can mark it. Now, there are some limitations on quality compared to something like acrylic, and we're going to get into that. Now, processing this can be done with both CO2 and fiber lasers, but not all can be done with both. And I'm going to explain the difference between. 30 plus watts is 10.6 CO2 micron for just engraving with your CO2 laser. You can have about 30 watts and above. Any lower wattage, it probably can still work with, say, 20, 25, but it's just going to be pretty slow. 80 watts and above for CO2 cutting. It is a denser material than, say, acrylic, and it does require a lot of laser power for cutting. Fiber laser for black marking will work. Any wattage for the fiber laser, we get a pure black mark onto it, which is an outstanding effect that we do not get on the CO2. And I will explain both types, CO2 and fiber laser, during this section. Surface yellow mark with a CO2, and then you get the black mark with the fiber laser. And so again, I will explain each of those. And then a flatbed laser or Galvo laser engraving will work for both styles, and so it'll both type of laser systems will work with this material. So advantages and limitations from the laser standpoint for this material. It does produce a permanent, durable black mark. It is a durable material, long-lasting. It is a UV stable material, and it's impact resistant. It is the main limitations for this material from a laser standpoint. It is very difficult to cut, and we get a very poor cut quality. And then the CO2 can produce a low engraving contrast. It's not very desirable on the CO2 side. The black that you see in the upper right-hand corner has been done with the fiber laser, and we'll discuss each wavelength and how it reacts here moving forward. Here's what the CO2 laser will look like when you engrave it. It tends to produce a yellowy looking effect from the CO2 laser. It doesn't require a lot of laser power, but it I do recommend air assist when processing this material. It does produce depth into the material, but again, the quality is yellowy. It's not really visually desirable compared to the fiber laser, and so just keep that in mind when understanding how this material is going to process. I mean, the sharpness of the characters and everything are good, but the quality or that color kind of yellowy contrast is typically a little less desirable, especially if you're doing like a barcode or something. It's not going to work very well. So this is the CO2 laser engraving onto the surface of it. I've left the masking on the back side. You just see and then it engraved, and then peel it off, just wipe the surface, any excess residue, and then you get that nice kind of yellowed finished result. Not much more to it. Again, I don't recommend barcoding or anything like that, but if you just need to throw a serial number or something like that onto it in a corner, the small characters are going to be legible. They're going to be readable, but again, it's not going to really pop out like the black that you would like to see. And that's where the fiber laser comes in. Now, cutting it is also, it is very cuttable, but the edge quality can be rough looking. And this is due to the carbon in the material. When the laser hits it, the heat reacts with that carbon, and we tend to get this crunchy, like black sooty residue that forms. It can be like rubbed off kind of with a kind of a pumice or even like a small amount of sandpaper. It kind of breaks away this carbon material, but it is not pretty. And when you get intricate little inside cuts, it's always going to look like that. Now, if these are screw holes that are going to be covered up, or if the edges aren't going to be seen, again, the tolerance and quality still cuts out beautifully. Just if you're going to see that edge in any way, shape, or form, then CO2 may not be the best process for this. I do recommend at least 80 watts or more. It does require a lot of laser power. Air assist with full pressure when cutting table, full vacuum table, vacuum cutting table. So you'd have the cutting grid with the vacuum underneath of it, blocking off all excess, because it does produce a whole lot of smoke and residue, which I will show in a video next. You do want to mask both sides, or leave the film that comes on the polycarbonate on both sides before cutting. If you're going to be engraving and then cutting, I don't recommend that. I would recommend cutting the parts separately, and then putting them in templates and then peeling and then engraving afterwards, because you'll see what I mean here in this next slide here. So this is I've left the film on both sides of the piece of polycarbonate, and then when we go to cut it, you can see what comes out of it. So this is why that film needs to be left onto the surface, because it'll stain the surface of the material. It is a very dirty material to work with, especially when cutting like this. So you see here exactly the reasons why you would need both a cutting table. I've masked off the excess cutting table, so I got a vacuum going through it, pulling that debris away. I'm also using air assist, punching it so that it don't damage the lens. The carbon inside will actually kind of hold the parts in place, so you kind of have to push them out, and then they'll fall away because of that carbon buildup. But as you see here, it is very dirty. It is a dirty material. Once you peel your film off, you can see the surface is beautiful, the quality and the edge is good, but you do get some distorted looking cuts, and it's just not a great material. Again, if the edges aren't going to be seen, you're doing screw holes that are going to be covered up, the edge is going to be seen, this is still a viable application. But I just want to make sure that anyone that is attempting or running this type of material understand the main limitations for this material. Now, marking with a fiber laser is by far the best with this material. Now, a fiber laser will not cut this material, so that's just not going to happen. But if you pre-cut or mechanically cut your plates or product, or if it's molded to a specific shape and then you need to place a mark on it, especially something like a barcode, certification code, lot numbers, stuff like that, it is now a readable barcode because of the contrast. The fiber laser will actually produce a pure black mark. And this is because the fiber wavelength doesn't react with the polymer. All it's reacting with is the carbon inside the actual plastic itself. And that carbon is being drawn out by the heat of the fiber laser. And so we get a beautiful high contrast black mark with the fiber laser. So here's a good example. This is on a flatbed. Flatbed CO2, or I'm sorry, flatbed fiber laser. I do hit it with 2 passes typically. Will produce a darker effect, and we get a nice high contrast mark onto the surface of the metal of the plastic here. It does almost have a kind of a reflectivity look to it on the flatbed system because depending on the resolution that you're running. So the fiber laser does a great job with this, and you do get that high contrast mark. It almost looks like it's been stenciled and painted, but it is far more durable and cannot be removed. Now the Galvo laser works just as well. The nice thing about the Galvo, this is actual time here. So this is not time lapse like the last one. So you can actually see how much faster. Again, the Galvo system's about 5 times faster. I like to hit it with more than one angle at more than one pass. And as you can see why, the contrast is outstanding. And then we get that nice black finished result. So this process is great if you do want to do a lot of marking on something like a polycarbonate. Galvo fiber laser is your best. Flatbed fiber will definitely work. CO2 will produce contrast, but as you saw earlier, it is kind of a yellow effect. And the cutting capability is, it's poor at best, if you will. Also, thickness, I didn't mention thickness of cutting can be limited as well by wattage. And so the stuff I'm cutting, I was cutting with an 80-watt laser, and I was only cutting 3 millimeter or close to 1/8 of an inch of material. So that you saw the speed of that. The speed of that cut you saw earlier was at regular time too. There was no time lapse on that. Couple different resources to which I buy my polycarbonate. McMaster-Carr, again, they're a very industrial material supplier. I also use Kerbel Plastics, which is available all around the United States, plastic supplier. You may also check with your local plastic sheet supplier. Companies that sell plastic by the sheet and just about all types of plastic. Typically, every local environment or local municipal city and stuff like that typically has somebody that sells plastic sheet. In most cases, they will also sell sheet polycarbonate. And it's usually much cheaper if you buy it in, say, a 4-foot by 8-foot sheet. And most of these companies will even cut it down to your laser size for you at a nominal fee. More common applications for this is barcoding, as I mentioned earlier, identification, traceability, serialization, gauges, surgical tools, signage, decoration, all very viable applications. And you see the little flow directors and stuff like that. You get catheters and you get a lot of medical type stuff because they're made of polycarbonate for the durability, where the fiber laser is going to give them a contrast mark onto the surface of the plastic itself. Anything that you can think of, but now you truly have an understanding what's possible with this material, what wavelength does what with the material, and just overall what it can do for you from a laser standpoint. Okay, polystyrene plastic. Polystyrene is a misunderstood material that I really like. You may think I've heard kind of that word before, polystyrene. You may have heard of the word styrofoam. Styrofoam is basically puffed polystyrene, if you will. They've injected air into polystyrene in its molten state, and it produces styrofoam. But polystyrene plastic itself is just basically the plastic that they would make styrofoam out of, but in a plastic sheet form. Polystyrene, also known as PS or styrene, is a thermoplastic and is part of the vinyl polymer family. However, it does not contain any PVC, so it is laser friendly. Laser cutting of polystyrene can be performed with a 10.6 micron CO2, resulting in a clean, smooth, slightly melted cut edge free of discoloration. Laser engraving of polystyrene can be performed with a 10.6 micron standard CO2 laser with results with a slight depth with a smooth, slightly melted, low contrast surface mark. So that's basically what it's going to do. Fiber laser does not work with polystyrene. There's no fiber laser with this. Nothing's going to happen when the fiber laser works with it. So a Galvo fiber or a flatbed fiber laser is not polystyrene friendly. So we're not going to get into any of that, and that's why, because it just does nothing. You can hit it with a fiber laser all day long, nothing happens. So it is a material primarily used with the 10.6 or the CO2 spectrum wavelength as the most common wavelength to respond to this material. So flatbed laser, 80 plus watts, 10.6 is recommended for any decent productivity. Realistically, any wattage will affect it. You can engrave it, especially if you're cutting it. I do recommend higher wattage because it is kind of a dense plastic. Air assist is a must. Cutting requires both sides of the material to be masked in order to kind of protect it, kind of like I showed you with the polycarbonate. A cutting table with a full downdraft vacuum is recommended if you have one, because this material does produce kind of a slag slide response, and I'll show you what I mean in some videos coming up. Engraving contrast is poor, but you can mask it and then engrave it and then produce color fill for certain contrast if necessary, and I'll cover that as well. So the advantages, why would you pick this type of material? It is low cost. It is a very inexpensive plastic to work with. It is permanent, durable, marking and cutting. It's very flexible and impact resistant. And this is why this material works very well. And I can also produce what a lot of people don't realize is some great detail. I mean, you see the sample here of this like honeycomb grid tee. The amount of detail I can get out of this material is outstanding. There are some limitations, though. Limitations, it can be difficult to cut. There are a few things that we're going to need to cover. It does have a low melting point because of the spectrum of thermoplastic that it is created and how it is created. It does not handle heat as well, but there are ways we can get around that with the laser. It does produce a low engraving contrast, meaning when you engrave into it, don't expect a barcode to read, for example. And it is a messy material to work with too, unfortunately. Different messy than, say, the polycarbonate when cutting, but I will show you what I mean here in a moment. So engraving it with CO2, standard engraving, as you can see here from this example, very low contrast. High laser power, 50 plus watts for engraving, slow speed, low frequency, low contrast is going to be produced when engraving it. It does kind of produce a little bit of a melty kind of look, but the edges are sharp, crisp, and clear. And if you want contrast, we would have to color fill it, and I will explain that. This was basically a single piece of 3mm 1/8" pre-masked polystyrene sheeting on a Speedy 400. And there at the bottom is the engraving settings I did to engrave that Trotec logo into the surface of it with that wattage. So here's what it looks like to engrave. You can see it does produce kind of a shadowy effect. We get a nice kind of a subsurface embossed look, basically almost kind of watermark look. It is recognizable, it is readable, but it is not the grass. The edges are a little bit rough. You can see the melty type look I was talking about right out of the laser. The edges are not as sharp as some materials like acrylics, but again, it is a recognizable mark. It is a subsurface mark so that it can't be easily removed. So there is the possibility, if you're just putting something like a part number, it is going to be a readable part number for throughout the time of the actual product, because it is marked subsurface into the plastic itself. Now, if you do want a little contrast, same process. This time it's pre-masked. And so what I did is I masked with a paper mask on the surface, and now I just engraved through it. Now, if I want that contrast, then you can just take a little bit of paint, and you can just rub that paint directly into the plastic itself with the mask still in place. So this is literally as we did it. Let it dry, and then we'll go ahead and just peel this mask off, and this is going to give you that contrast. And so if you want that contrast into the surface, it's a pretty easy solution. I just rub it in with a glove and a finger. You can use a paintbrush, you could spray it, it really doesn't matter. But now I get that contrast, subsurface, high contrast mark. The edges you can kind of see from the Melty is not perfectly sharp because of the type of material it is. I don't modify any of my photos or change any of them. This is how it came out of the laser, how it went through a paint fill. And this product here is about a business card size in reference for 2 by 3.5 inches, for example, as an example of what size this graphic was. Now, cutting polystyrene can be a little trickier. You need to use air assist. If you don't have air assist, it just produces a plume effect. The cutting table with a full vacuum downdraft. What that means is some of the cutting tables on, say, the Speedy 300 or the Rayjet don't actually have a vacuum downdraft. It can be cut, but it's going to be difficult. The vacuum actually kind of holds it down, and what it does is with the air assist pushing through the cut, and the vacuum, pending you have all excess material or excess components of the cutting table blocked off. I usually use a paper to block it off, so it creates a vacuum. So as it's cutting through this material, you get a push action from as the beam hits it, the air assist kind of pushes the molten material through, and then the exhaust from the vacuum on the cutting table, pending the excess cutting table is covered up, pulls through, giving us a much nicer cut. This is recommended for doing this, but in order to do that, we need to mask both sides of the material with a paper mask, or leave the mask on the material that comes with it. Low frequency, slow speed at high power. The one drawback, as you see in the lower right-hand corner here, is the residue that's left behind. This is what I mean by being messy. It literally produces this white, sticky residue that comes out of it as that push-pull action comes from the air assist. But when you do this process well enough and you do it right, you mask both sides, you use air assist, you cover up all your vacuum cutting table so that you have a vacuum pulling through, we get a very, very clean finished result. Here are the settings at the bottom here for the 1/8" polystyrene cutting, using a Speedy 400 120 watt laser with air assist at 100 power, 0.5 speed at 1000 hertz. Here's an example of a small product that I'm going to actually cut out. So this is that one that I showed you kind of at the beginning of the slides for this product. So pre-mask on both sides. The cutting table is completely covered over except for the location where my part is at. Air assist is pushing and cutting through. The exhaust is now pulling through the table, producing a vacuum so that we get that kind of push-pull action. And so therefore, we're able to cut through this not very large part with very, very high detail. And then we're able to then just pop it out of the machine. Now, the back side of this is going to be rough. And this is why the mask, you can see almost a slag type plasticky residue. So there's the front, a good photo of it. And then I'll show you the back as well, right out of the laser machine. And this is why the mask is needed, because all those little plasticky slags, if you don't mask it, will stick to it. And so if we go ahead and peel the mask off now, we're able to take that out. Take out all that extra residue, and it literally just breaks away. It is kind of messy as you're peeling the mask off, but now we got a high quality, premium grade cutout, and I'm able to achieve a consistent 35 thousandths or 0.9 millimeter ribbon wall on a material with this low of a melting point, which is amazing, especially for this type of plastic. It's not perfectly straight, as you can see. I don't edit any of my photos. I just zoomed in as is. You get a little bit of distortion here and there. So it's not quite as good as, say, a molded look, but it does a great job, especially for an inexpensive thermoplastic like polystyrene. Some of the more popular applications because of the cost is signage, advertising signs, engineering product and structures, packaging, when injected with polystyrene or to produce styrofoam, commonly used with appliances, consumer electronics, switchboards, architectural models. Great material to work with, inexpensive. It is a little messy, as you saw, but when it comes to, if you do it right, you use the air assist, cutting table, vacuum, you can do some very, very nice effects with this material. Again, here's some more resources if you want some masking. JDS does not sell polystyrene, but they do the transfer tape and masking tape if you are interested in that. McMaster Carr and Kerbel Plastics, again, two plastic suppliers that I typically use, or suppliers I typically use for more of the industrial materials like this. Okay, let's go into Trolleys Textures. Trolleys Textures is a very industrial, durable signage type plastic. It is based on the concept of your engravers plastics, your plastics that are just thin surface, designed more for signage and stuff like that. The reason I put this one into the more engineering, industrial looking type compound is Trolleys Textures are a dual layer acrylic based materials best used for tough environments. So this is the type of signage that you would put up in the greasy, grimy workshops and auto body shops and industrial type environments that are more prone to damage, UV, scratch, any of that external type environment, you know, manufacturing facilities, labeling for that type of stuff, where there's possibility of harsh environments, UV, there's possibility of being touched a lot and or physically touched, and so they're going to actually be rubbed away, for example. This is a textured matte surface, non-reflective, strong, easy to clean plastic that is UV stable, weather resistant, suitable for indoor and outdoor use. And so it's basically a super strong signage material traditionally used in your manufacturing, signage, harsh environments. And that's why it is advantageous for this type of seminar. And so it is commonly used more for your signage because it is produced multiple contrast, indoor, outdoor, data tags, labels, basically any durable signage for dirty environments. Works mainly, it is a flatbed laser, 60 watt plus 10.6 CO2 laser. Air assist and cutting table is recommended if you're going to engrave and cut it. If you're just engraving it, you don't necessarily need the cutting table, but if you're going to be doing both, which most do, then you would need those for processing this material. Advantages, as I mentioned earlier: UV, weather resistant, flexible, high contrast, impact resistance, and easy to clean, because it does have a textured surface so that it is you don't get the reflectivity that you would get on your traditional engraver's plastic. Now, there are some limitations. This material is not your engraver's plastic. It doesn't respond the same way as engraver's plastic. It requires about 3 times the laser power to process versus your standard engraver's plastic. Of course, it does have a foul smell after about 36 hours after processing, just like most plastics, and does require the residue cleanup after laser processing. And it's not as clean of a material as your traditional Trolleys plastics or your Surmark, IPI, Scott plastics, and your normal signage materials. So in order to engrave and cut, 50 watts plus, slow speed, low frequency, melted looking engraving, color fill for contrast. These are all things that can be done, but the contrast on this does actually produce the contrast of the core layer. Now, sometimes people will do color fill on it so you can mask it, and then you could say maybe do a different color as well as the color of the engraving process. So that's the nice thing about this material. If you need 2 colors, you can mask it first. Then you could color fill it afterwards if you want. But it is a great material to work with if you need that high durable UV cable durable material for that. And here's the actual process of an engraving. So this is a black core with a yellow surface. My video will run here. There we go. So what this does is it works just like in any engraver's plastic. You will see a little bit more staining because the cap layer or the top layer of this material is much thicker. And so it does require a lot more laser power to punch through. Sometimes it is maybe easier to run multiple laser passes because this way you don't remove as much residue in between. It can give you a little bit cleaner response so you don't have that residue you see here. So that black residue, you know, the reason I do it in one pass in this case is because I will typically clean it up with a Hexane Cleaner. Hexanes are nice because you don't need to worry about any residue. Here's a little QR code if you want to see where to get that. Hexanes work nice, a little bit on a rag. Make sure to wear gloves and just dub a little on the rag and it'll wipe it right off. Most cleaners don't work this well with it, so this is why I was able to run this in one pass. If you don't have hexanes, then run it in 2 passes and you get a cleaner response. And then we're going to have that nice durable, you can see the texture here onto the surface of the material. This is kind of a good example of a fire evacuation sign. Durable, it could be touched a lot. People could be kind of referencing it for a map, for example, and it's going to be put up for the life of a building. So this is a great example of where this type of material would be used. Here's a few other examples of common of some of the contrast and the differences between the material. And this is actually sold through Trotec USA through our engraving-supplies.com website. If you're not familiar with that, you can scan this QR code to order this material. Okay, moving on, polyurethane foam. This is a very popular laser-friendly material that I like to work with. Polyurethane foam is a member of the polymer plastic family. A flexible foam has a cellular structure that allows for compression and resilience, providing a cushioning effect. CO2 laser reaction, the foam absorbs the energy of the heat, basically vaporizes the surface of the material, produces a clean, controlled depth engraving and cutting of the material. I like to use the grayish stuff because you do see a little bit of a yellowing effect. You can kind of sort of see it in the engraving here. If you look at the edges of this little part that I cut out, the edges will turn slightly yellow. So the real bright white version of this foam just exasperates these color contrasts. And so sticking with the grayish ones make it look a lot nicer. And so I tend to stick with most of my samples being the grayish looking foam. The most popular applications for this material is your protective cases, packaging, cushioning, soundproofing type applications. Because the laser cuts beautifully, you get that nice flame polished edge cut with high contrast. It's great for your packaging, your prototypes, your toolboxes, just for presentations, anything like that. It's a real nice application for that. Requirements, this is only a CO2, mainly a CO2, I should say. There are the possibility you can actually cut some versions of foam with a fiber laser. So I've had decent luck with it, engraving and cutting it with a fiber laser, but I'm not going to get into that too much because it is not that popular and it just doesn't work as well as a CO2. But just so you know, a fiber laser will work with especially the grayer foams, polyurethane foams, and I've even cut it with a fiber laser. But like I said, it's not as pretty of a response as a CO2, so I'm not going to really showcase it, but I did want to mention it. 30 watt plus for engraving and cutting up to 1 inch. Then 80 watt plus for cutting thicker than 1 inch. 2.5 inch to 4 inch lens if you're cutting inch or more. Cutting table is recommended. Downdraft vacuum table for more than 1 inch because this is it can be a flammable material, which we'll get into. Limitations of this material is permanent, durable marking and cutting. That's what I like about it, is a durable material, good chemical resistance, density variation. You can get it in lots of different densities, so softnesses. So you can get really soft versions of it, or you can get some real dense versions of it. All works very well with the laser. It does have a low melting point and a foul smell. But that's like any polymer when processing with your laser. Typically a smell, even outgassing after you take the products out, will last no more than a day or two. After that, the product is clean smelling. So just try not to deliver to customers immediately afterwards if that's going to be a problem. You do, of course, also have a little bit of a darkening or yellowing cut edge, as I mentioned earlier. So the grayer foams work much better. And this material is very flammable, so you want to take very close eye especially if you're cutting this material. Thicker materials, if you don't have enough wattage, good enough air assist, this stuff can ignite very quickly and get away from you. So keep very close eye on this material should you decide to cut it, especially thicker materials. Polyurethane foam can be ablated with a CO2 or a fiber laser to produce engraving, detail, and depth. This be done to control. Oh. Sorry, my system just went off. One moment. Okay, sorry about that. Just so you know, the polyurethane foam works with air assist. I do recommend air assist if you're cutting it. 30 plus watts for engraving it, and just a standard 2-inch lens. So that is the process of working with this. The sample you see here on the right is a microcellular polyurethane foam. This means it's a much smaller, the actual cells of the foam are much smaller, and so we're able to achieve a much higher contrast. The 3M makes it, the microcellular. Also, Rogers Poron is a brand, but this is a great material. It's got that foamy, real kind of dense feel to it, but it engraves beautifully, as you see in the samples here. The recommended response for this or accessories needed is air assist, 30 watts plus for engraving, and then 2-inch lens is necessary for the surface of this material to be engraved. So here is a standard polyurethane foam for engraving, and you can see here as an example how the material forms. And this is only run at 125 dpi, so very low resolution. This is about a 3-inch by 6-inch block of foam, 1.5 inch cut out sheet, but you can see the contrast is outstanding. Good contrast, doesn't require, and this is actual time. So we're engraving it. There's no time lapse on this. The laser is able to vaporize it because we're taking such a short amount of passes. Now we get that nice depth contrast into the surface of the foam. It's a great material to work with if you want that contrast into it. But it does have some limitations, and that is mainly in the cutting side. So engraving it works good. You got to be careful not to go too deep. You can go deep very quickly, and it does not require a lot of power. Cutting it is also very, very nice. And the fact that it does produce that kind of nice flame polished kind of edge cut quality, and your cut quality is very, very good. But in order to get the cut quality, there are quite a few limitations. And there's a big warning on the bottom of the screen here. As I mentioned earlier, the flame polished or the flare up of this material is very, very high. It has a very high risk. In the past, I've actually done videos on how to sustain some type of any type of flare ups, and this is honestly the material I use to as a show as an example of how easy it can get away from you. So keep very close attention, especially when cutting thicker materials. So polyurethane foam requires air assist. Air assist for cutting through it is an absolute must. Cutting table is also a must. Otherwise, that excess heat from the backside is going to cause a fire or flare up. And so you want to make sure if you don't have air assist in a cutting table, unless you're cutting very, very thin material, I don't recommend cutting this material at all. Vacuum table downdraft for anything more than 1 inch. And so if you're cutting thicker material and you don't have the vacuum downdraft, I don't recommend cutting any more than 1 inch of this material. 30 watts or more is all required to cut up to 1/2 inch of this material. 80 watts plus with a 2.5 inch lens, I would recommend for 1.5 inches or more, or I'm sorry, 1.5 inches or less. 120 watts for up to 4 inch. I've actually cut up to 6 inch thick of this material, but it depends on also the density. And you run a much, much higher risk of fire or flame or flare up when processing this material as the thicker you go. And so that is a requirement for this material in order to process it properly. The other thing that will make a big difference is the density of the material itself. So the higher the density of the material, the more power it may require. And in those cases, you may also require higher wattage. And so play with it. Ask the questions. Definitely ask us if you have any questions for this material. We are definitely standing by should you be able to have any questions on this material. My suggestion is to order a small amount of it and play with it before you expect that it's going to perform exact. Because density can vary, manufacturer can vary so much, and the material can get away from you very quickly. So keep a very close eye on it, especially when you're cutting thicker materials. So here's a good example of where I basically took photos of some tools and then created an outline, and then I sent this to the laser, printed this to the laser, stuck it into the foam, and then cut out the individual cutouts of the toolbox. And so this is a very common application. You can see the little flare on the back side, and this is only cutting through right here is about 1 inch thick material. So cuts beautifully, nice clean cutout. pull the parts out of the place, and then of course you can place the tools into this. This is as simple as taking the product on the place the product on a scanner bed. I trace around it to create the tool outline. Once the tool outline is done, it can then be arranged to create a toolbox outline. But you can do all kinds of different type of applications. Toolboxes, gun boxes, product displays are a very, very popular application for this material, especially using, say, two-tone, where you buy the polyurethane foam with adhesive backing, and then once it's been cut out, you peel it and stick it to a different color of urethane foam, or stick it to a color of plastic behind. This is also great for toolbox or tool identification. What that means is you can look into a toolbox at the end of a shift, for example, and see if there's any tools missing. This is very commonly used in the aerospace industry because they have to track all the tools at the end of the shift. They can't accidentally have, say, a tool be left inside of a very sensitive component or a jet engine or something like that that's being worked on. So all tools need to be tracked and traced at all times. And that's a very common application for that industry. Here's where I buy my polyurethane foam. Again, like a lot of the engineering industrial materials, McMaster-Carr is a powerhouse. I think they got 500,000 products now, but it's a great source, and they typically ship anywhere in the world. Or you can, of course, contact any local supplier that you may know of that creates or manufactures or supports or supplies polyurethane foam. Here's another one that we don't get into very often, and that is ceramics. Ceramics is a kind of a misunderstood material, especially with lasers. Some people think of ceramics, being more like your dinner plates and stuff like that. But what I'm talking here is going to be more your industrial ceramics. Ceramics are hard, breathable, heat-resistant material made from mixtures of clay, earthen elements, powders, and water, and then are shaped into desired forms, and then are fired at high temperatures in an oven or a kiln to create a inorganic, non-metallic, solid component. The benefits of these is they're usually extremely capable to handle high temperatures. And so they're used for heat shields. They're used for particulate shields. They're used for products that are going to be sensitive to some of these harsh environments, mainly heat. Well, the nice thing about lasers is that there is no actual temperature of a laser, especially CO2 laser. The temperature of the laser is the vaporization point of the material that laser is hitting. So the benefit of that is we can exceed the temperature needed to melt the ceramics to produce contrast. So we now have contrast marks on ceramics that are designed to go into ovens for thousands of degrees. And that is the great thing about lasers and ceramics. Some of the more common is your porcelain. Porcelain is going to be like your dinner plates. It's mainly used with CO2, but we're really not going to get too much into that because this is more about your engineering, industrial type ceramics. Now, alumina ceramic, which is more common in this, work both with a fiber and a CO2. Aluminum nitrate ceramics are primarily used with CO2 laser only. Aluminum silicate is fiber laser only. Macor, which is your machinable glass ceramics, work exclusively with CO2. And then your silicon nitrate, which is used to design and run or create like knives and stuff like that, are typically done with both fiber and CO2 as well. And so we're going to go through some of these different ones, and I'm going to show you some examples. And what I found to be quite amazing how well lasers can react to these materials. Some of the more common applications that we're going to cover is more your, like I said, ceramic coatings, electrodes, heat protection, culinary knives, tiles, and things like that. That is where we're covering today. This is not your ceramics that are used more in the decorative and plates and crafting and to create vases and plates and or dinner plates and stuff like that. We're talking more industrial applications in this case. So process requirements. Typically CO2 or fiber, depending on the type of ceramic. 60 plus watts on CO2. It does take a lot of power to mark some, depending on the type of ceramics. As I explained, the different ceramics support different wattages and different types. 20-watt fiber laser at least for marking any of the ceramics that support fiber lasers. Flatbed CO2, flatbed fiber, or flex machine can be done with both CO2 or fiber on the Galvo system, depending on the ceramic type. So a lot of different kind of depending on the ceramic. And as I explained earlier in the previous slide, what ceramics work with what wavelength or type. So what are the advantages and limitations of ceramics? Ceramics are extremely hard and durable, heat resistant, wear resistant, corrosion resistant, but they do have a weak tensile strength, poor shock resistance. So if you drop it on the floor, it's gonna react more like glass. It's gonna fracture. It can have a difficulty producing dark marking, and there is just no chance of cutting it with the laser. So cutting this material is out. This is primarily marking is all we're going to cover in this segment. But as you can see in the sample I'm holding here, this is just a welding tip of the Alumina Ceramic. The contrast is outstanding. We're able to get that black, almost kind of like a Surmark, in the fact that it takes the ceramic coating and actually fuses it, turning it to glass, and produces a black mark, which is a great effect with just a standard CO2 laser, which I'll illustrate here. So here is like a clear ceramic, Alumina Ceramic. When they have pigments in it, we tend to get a blacker mark. Here's an example of, a fiber mark versus a CO2 mark. And what the different wavelengths do. The porcelain, of course, CO2 only. Over on the right here is the alumina. You can see both fiber and CO2. Neither one of them is great contrast, but it can be marked with both wavelengths. Aluminum nitrate is kind of your darker ceramics. It'll turn kind of a whitish with CO2. Unfortunately, I was not able to get some in time before this seminar. It's kind of difficult to find, but I do know from previous examples that it does turn bright white when engraved. Aluminum silicon is a fiber laser only type material. Macor is a black, it will turn pure black like that previous slide I just showed. And silicon nitrate is both fiber and CO2, more for knives, which I'll show you as well. So we're going to start out with the silicon nitrate. This is a knife blade, which is a very common application for knives and cutlery. The nice thing about this that blew my mind, actually, when I started engraving this is actual speed. Before I go into the time lapse, the contrast is unbelievable. I mean, it literally looks like I just silk screened black onto the surface of this ceramic knife. So it actually produces that unbelievably high contrast black mark onto this ceramic, and it was really fast. I mean, this entire mark was 35 seconds to engrave. In production, this becomes a very viable application. Because this application is now the fiber laser, which I'll show you an example in a bit here on this same material, is kind of that bronzy brown effect. And that's the difference. And so both wavelengths work on this type of ceramic, but it is a great application for this. This is the Alumina Ceramic that has been pigmented. But again, as you can see here, nice black mark onto the surface of the ceramic. And these are designed, this is a welding tip. So this is designed to be on the front of a welder, so you can understand how much heat is involved or this material can support. So again, the great contrast. I like the tinted versions of these. I do get a darker mark versus, say, the white ones. The white ones are more of a bronzy brown like you saw earlier. Of course, you can do it, of course, on the rotary as well. There we go. Here I'm actually putting a gauge mark. Sorry, it seems like we're having a streaming issue here, but the rotaries allows you to rotate 360 degrees around, whether or not you're doing ceramic type marks like this, or if you're doing them on flat. Same type process. You do get that nice black mark all the way around it, and it is a great application for this type of material. So here are some other examples. Just ceramics are one of those, especially your industrial ceramics, most of them will work with the laser. There are so many different types out there, and I wasn't able to, it's not an easy material to just order. It's not something you're just going to say, hey, where's your nearest ceramic material? It's very specific more to industry. So my main reasoning to kind of illustrate there, and here's the knife that I mentioned earlier. The top one is the fiber and the bottom one is that CO2. CO2 is much blacker, but the fiber laser also produces that that bronze effect as well. But it is a high contrast mark. You could do any type of mark you want onto the surface of this material. All of these types of ceramics work with the laser. Play around with it. If you have any questions, definitely let us know if you and we can help you out. It's another reason our applications lab is available for you for these type of materials for testing. Okay, so here are some other representations or some examples of where to get some of the more higher end ceramics. This is based on some web research that I did. These are some ceramic manufacturers that actually make this stuff. So if you are interested in kind of looking for, I've done a lot of work with Trotec in the past. They make some unbelievable ceramic materials. Most of it is the Alumina Ceramic, but a lot of these also support some of these different types and abilities in the ceramics. Okay, elastomers and rubbers. This material is, I'm not going to get into much more. I mean, elastomers and rubbers are commonly used on the CO2 side for rubber stamps, which I'll touch on, but we're not going to get really into that since this is more for engineering and industrial type environments. We're going to touch more about what these are used more for your gasketing and materials that are commonly used more for this industry. Common elastomer rubbers are members of the polymer family that are very elastic, typical silicone, latex, neoprene, butanol, natural gum type rubbers. Most rubbers are going to be laser friendly. They engrave, they cut, they mark, or engrave and cut. I mean, sorry, they don't really mark because you do produce a little bit of depth into it. I mean, industry has used them for rubber stamps for years, but for just cutting out materials like industrial labeling, gaskets, spacers, but you can also do, of course, stamps and that type of stuff as well into this material. Common with this is flatbed CO2, 80 watt, 10.6 micron for cutting and engraving, air assist and cutting table if you're going to be cutting. But the engraving contrast can be poor. It does engrave. Typically, it's used more for rubber stamps for embossing and printing or onto the surface of it, but it is not really designed as, you won't see a lot of engraving into the surface just for the sake of reading it, for example. It is legible, which I will illustrate here, but most of what is processed with this material is for cutting. Advantages: permanent, durable, marking, cutting, flexible, impact resistant. I said flexible twice, I just noticed here. But it also is difficult to cut some types. And that's something I do want to make sure you understand. Sometimes I've come across rubber that if you don't have enough laser wattage, you cannot cut through it, especially like the high temperature silicone rubbers. This is because they typically have a little carbon in it, kind of like the polycarbonate. But I found that if you have a 50 watt laser and you're not able to get through a 3 millimeter thick piece of rubber in one pass, you can hit it with 10 more passes and it'll never cut through. But yet if you have an 80 watt laser, it'll cut through in one pass with no problem. Some of these rubbers will allow a part of the energy to go through, and then it'll absorb it into that carbon to the point where it will not ever cut through. So they can be difficult to cut. If you don't have enough laser power, you may find that you will not cut through it. But yet 10 more watts and you're cutting through beautifully and the edge quality is great. So that is something that you need to understand on some different types of rubber. They also have a very foul smell. It is probably one of the worst materials to work with when it comes to smell. It produces a smell that is just awful, and you really need to make sure to outgas, even ventilate trash cans from scraps and stuff like that because of the outgassing, because this stuff can have a lot of smell. There are some rubbers out there that have reduced that, especially your lower odor rubbers, which you can buy now. But if you're just buying off-the-shelf industrial type rubbers, you do definitely want to keep in mind that there will be a smell associated from the scraps and products that you're pulling out of the laser. It is a dirty material. The contrast is low when engraving, but it is legible, and it is messy material. Dirty and messy, same thing, but just kind of putting a point to the fact that just understand this material does require a lot of cleanup afterwards. So you can see the engraving contrast. It's okay. I'm able to, and this is a 10-inch by 10-inch sheet that's been engraved. I do have a legible, readable barcode, actual photograph on it, but when it comes to comparisons to other materials, the contrast is, middle of the road, if you will. It is cuttable, it is engravable. In order to engrave it, typically air assist, you do get a flare that comes off of this, and so you want to use air assist anytime working with this material, whether you're engraving or cutting it. Slow speed, low frequency, low contrast is going to be achieved when processing the material. If you are interested in rubber stamps, which I don't really get into, I do have a QR code here for you, though. You can take a look at that, and if you are interested in maybe moving forward and just being interested in cutting and engraving rubber stamps. And so we're not going to get into that because this is more your engineering, but it is a very, very viable application. And honestly, for polymers and rubbers, this is the application that Trotec started with. Our sister company, Trotec, actually sells and started the company by manufacturing and producing rubber stamps. And so that is kind of where Trotec came from. So definitely some heritage there. But when it comes to engineering materials like that, rubber stamps aren't as popular anymore. Now, cutting it is something that is very popular and still very, very viable because you have the ability to cut, say, a nozzle or cut a gasket type property, cut out of the metal or the rubber at moment's notice. And so being able to create these on demand is huge. Air assist is required. Small hole nozzle with high pressure air running through it. Cutting table with full vacuum downdraft. High laser power wattage is necessary in order to cut. It is definitely productivity is going to be associated to laser power. The more you have, the faster you're going to be able to cut. And in some cases, you won't be able to cut at all on thicker rubbers or even thin rubbers with certain wattages. So I would suggest running a test, contacting us. But there are so many different densities and types out there. I can't just give you a, hey, this wattage works with this thickness because there are so many different variations. I do suggest running tests if you're not sure. Slow speed, low frequency when cutting are recommended until you penetrate. You want to cut through rubber in one pass. Multiple passes are not recommended because they typically do not work. So if you can't get through in one pass, you probably won't make it through. And even if you do, the quality is going to be poor. So single pass cut, high quality will be achieved if you can do that. And here's an example of cutting just your standard off-the-shelf silicone-based rubber. And you can see the kind of flare that comes from it, the carbon kind of dust that forms around the edge from cutting your off-the-shelf. This is not rubber stamp material. This is industrial, engineering-based silicone rubber. But you can see the carbon that comes off of it. And this is why the air assist and the cutting table are necessary. And we're cutting basically a whole bunch of sheets of gasket or spacers in this case. Once they're pulled out of the machine, definitely need to kind of wipe the edges because the edges do have a little of that carbon buildup on it. But once they're wiped off, you get that molded, finished, clean, finished look onto the rubber. And it's a great material to work with. But again, as you saw in that video, it is dirty material to work with as well. So most of your cutting applications, spacers, gaskets, and rubber stamps are the primary application for this material. But if you need to cut it for anything, then of course the laser is a great alternative tool for processing this material for these applications. Here's a couple of different resources again for this material. Trotec being the manufacturer for rubber stamps for, I think, over almost 100 years, I believe. And so you can contact them if you're just looking for rubber stamp or just basic sheets of rubber. Or, of course, if you're looking for more of your industrial type rubber type materials, your high temperature rubbers, your different types of rubbers, McMaster cars usually, at least where I get it, or wherever you purchase your rubber from. Okay, this is the last segment, and then we're going to go ahead and move forward with some Q&A at the end. This is the Tessa secured laser tape. This is a specific type of tape that is very common in the laser industry and used in the engineering, like industrial type harsh environments, kind of like the textured plastics, as I mentioned, the Trolleys Textures plasters that I mentioned earlier. This is more of an harsh environment type secure laser tape for labeling and badging with an added bonus. Tessa Secure Laser Tape is laser engraved and cut. Tessa model label offers superb durability in harsh conditions and can be laser marked and cut into any shape you want. It's easy to engrave, but the benefit is that it's secure. It can be processed in low laser power marks in both CO2 and fiber wavelengths, removing the hassle of buying pre-cut or anything like that, labels for ribbons for thermal printing, for example. In addition, the exceptional adhesion qualities produce a standard tamper equivalent design that prevents the label from being removed in one piece after it's applied. So this stuff is ideal because it's a laser-friendly tape-like material, and you can buy it in rolls, you can buy it in sheets that give you the ability to produce a permanent label that can never be removed without proof. So there's no way to actually pull that label off and then apply it again, for example. It actually fragments and chips away when attempted to be removed. So it is a permanent, adhesive, laser marked, high durable, permanent mark with tamper-proof abilities on it. So this is a great material to work with if you have these needs. Commonly used in asset tracking, UID tags, labels, automotive, aerospace, manufacturing, government, medical, technology, and defense markets. So an extremely popular material when it comes to that. Just about every product these days needs some type of label. And in a lot of cases, for security reasons, they don't want to be removed and they can't be removed. For liability reasons or tracking or tracing capabilities, you want a part that is, once it's applied, it stays on. But you also don't want it to be printed because harsh environments can damage it, or salt sprays or acids and stuff like that can erode away printing much easier than it can engraving, because engraving is a subsurface into the material mark. Typically, flatbed CO2 and fiber is what's used for this material, but a fiber Galvo system would work as well. And you can even automate it should you want to put it on a spool and hook it into automation as well. This is possible as well. Air assist with wide mouth cone on a flatbed machine is recommended. Only 30 plus watts for engraving and cutting. 1.5 and 2 inch lens on your flatbed laser. Cutting table if you're going to be cutting it out. The drawback on the Galvo laser is it's not going to really cut through both layers, including the back paper, but it will cut through that front layer, giving you a kiss cut so that you can actually cut through and then just peel it up afterwards, which is nice. CO2 will do that as well, but both wavelengths work with this material. The big advantages, of course, with this material is it's a permanent, durable marking and cut. It's tamper-proof, chemical resistance, and it produces high contrast. So you have that durability and reflectivity, so that it's great for barcoding. It's great for the barcode scanners and contrast. The only real limitation to this material is it is kind of expensive because how it's produced it's more difficult to produce, and so it does have a higher cost margin to that, and so it needs to be justifiable. If you're just doing a standard label, I wouldn't use this material for standard labels unless it needs to be security based. So this is the material actually running. You can see this is a sheet. I've taken an entire sheet here, and then we'll engrave the entire graphic, multiple graphics, of course, with a different serial number on each one. You can do that. That's the other nice thing about the Galvo fibers is the serialization is built in, so you can have it automatically plunk out different serial numbers per label. And it can also change the QR code or the barcode or UID code or the linear barcode all at once. But as you can see, nice, clean, high contrast mark. I've done a cutout and a kiss cut. So all you have to do to take this material off is that you just go ahead and just peel it. And then once it's applied to the surface of a material, it cannot be removed. So here I've applied it to a piece of stainless steel, and then we're going to go ahead and try to remove it. And I tried my darndest, and what it does is it literally fragments away. So little pieces and picks, and I don't care if you're taking a blade to it, you cannot get this stuff to actually come back off without fragmenting, indicating that it has been tampered with. And if it has been tampered with for security reasons, you would know very, very quickly. And that is the true benefit of this stuff. High contrast durability and tamper-proof ability with the laser engraving, the ability to handle chemical and with durability of tamper on this material. So here's where you can get it if you are interested. Partner of ours, Code Source, which also sells Trotec Laser. You can contact them. QR code here, and they are going to comply or sell with the compound, the Tessa tape compound for the laser systems. Here is the Here are some information on the UID marks for some resources if you are interested in some industrial type environments for doing this material. Okay, we got a few monthly updates here, and those monthly updates, just a little bit of requirements of the month. So if you have any questions, again, let us know. April month, the deal of the month, of course, is actually on our Trolleys texture material. The Trolleys Textures produce, we have a 20% off Trolleys Textures. If you are interested, just type in voucher code APR-promo-2021 when you're ordering that material. It cannot be combined with other offers and can only be redeemed within the United States through the month of October. Well, I would say that this month. Sorry, that was a typo here. Through the month of April. Some exclusions may apply. And now, don't miss last month. If you missed last month's seminar, third Thursday, then you can scan this QR code on Broaden Your Product Line with Laser Accessories. That will be available online now for last month's seminar to the public. So you can scan this QR code if you want to watch it now, or you can go to our YouTube channel, which will be launched public either this afternoon or tomorrow. All right, we're now going to move forward here, and I'm going to be joined by Andy Wellens. Andy Wellens is our industrial sales manager through Trotec.
Very sorry, I lost my volume.
Are you there, Andy?
Now I can hear you. Thank you.
Okay, sorry. I just realized my batteries died. I had to change them out. Long seminar killed my battery. Sorry, I noticed it flashing there. So you can hear me then?
Yes, I can.
All right, excellent. Good. Thank you for joining me, Andy. We've gone an hour and a half, so we're right on track here. So Andy's going to join me today to kind of help me and answer any of those questions, especially from the sales manager standpoint, when it comes to maybe some of the questions that you may have on that. Andy's been in this industry for what, 20 plus years, right?
Yes.
Good. All right, so we're going to go ahead and go through your questions now and answer them as best as we can, and hopefully get you guys on your way for the day after we're finished. Okay, I was a little bit late. Can you please let me know how long the metal marking compounds last on a product? That is a great question. I get that a lot. Metal marking compounds are an indefinite material. It is a glass fused metal. In the past, they tended to fade a little bit in UV, but later versions, about 10 years ago, they became UV stable. They're going to last virtually indefinitely. So as long as the metal itself lasts, you should have a durable, permanent mark. So much so, I believe they use this compound in components of the International Space Station. They even mentioned. So it is for outside. So it's a very durable, high contrast, UV stable product, and you can expect that it's going to last indefinitely.
I'm not sure if you mentioned earlier, David, it is available in other colors other than black as well.
Yeah, I didn't mention it, and I don't mention it on purpose because there are other colors, honestly, I don't approve of them. They don't work very well. They're too finicky, too inconsistent, and expensive, and every person, including myself, that have worked with them, I just can't give my approval for them. It's a waste of time and money. Stick with the black. There are a few kind of chrome colors or like a bronze color, I believe, and stuff like that that kind of sort of work. But I've just not had a lot of success with them personally. So it's definitely something good to bring up, but I don't personally recommend them. What if there are no preset settings? How do we know what settings to use for using a metal marking agent on a metal marking with the CO2 laser? That's a great question, Kelly. And you're going to find that unfortunately happens with a lot of this, especially these more exotic materials that are not preset for you. I have a example of kind of how to create settings on our YouTube channel. It's basically called the power wheel. And so it kind of allows you to kind of put in all different power settings and then to kind of help you dial in settings. I would suggest going to our YouTube channel and then typing like a keyword power wheel or power settings. And I have a laser hack that really kind of explains and shows you step by step. It includes the files to kind of how to create that. It comes down to a lot of trial and error to kind of find that setting, but I have produced a lot of videos that will help you dial in those settings and so that you can create settings yourself.
In the Galvo software, there are templates included, so you can, it's a parameter finder templates. So on any given material, you can run those templates and it gives you the range of possibilities with different frequency, speed, and power. Oh,
that's great to know. It's funny. I don't think I've ever really had to use that one. I've always dialed it in manually. So yeah, there are resources for you on the flatbed. Like I said, watch the video. And as Andy just said, there's preset if you have a Galvo system to use the built-in features to dial in those settings. All right, next question. How durable is the Surmark in harsh environments? This is it's a great question. I mean, they're durable more for visual purposes, but it depends on the harsh environment. It really does. The only thing that I have found that they may not be durable because it is a glass fused mark is that, you know, if there's going to be shearing effect onto it. So for example, if you put a serial number on the bit of a tool that's going to be sheared with a bit or something like that, it may not be very durable. If it's just going to be for visual labeling and stuff like that, it's going to be very durable. So from my experience, the durability is based on the environment that it's going into, and it is something you may want to double check. Have you come across anything different on that, Andy, with these compounds for durability?
No, not necessarily. I think you're correct in that depending on how it's applied, how well it's applied, and then what the particular environment is, as far as salt spray and other harsh chemicals.
Agreed.
Could affect it in the long term.
Yeah. And I'm sure their websites actually do kind of explain a little bit more on that, since the companies that manufacture them are going to have a lot of certifications and requirements and durability testing that they've most likely done. For annealing stainless, you says it takes some time. Do you mean longer times on the laser, or the time it will take to resetting the laser after that to reach the final color? Andy, maybe a good one for you, since you're really good on the Galvo side.
Yeah, David was referring to the amount of time it takes to create the marking. It does take longer to create that annealing. There's no resting period required. It can heat the material up considerably, so you would want to be careful once you've done an annealing, especially if it's a thinner material. When you pull it from the laser, just be careful. It may still be warm, but the result is immediate as soon as the laser engraving is complete.
Yeah, agreed. The main reason it does take longer is because we usually have to run at a higher resolution to build up that heat. And so that's where the time comes. Good one for you, Andy. Any movement on getting the Mopa onto a flatbed?
No, it's something that we considered early on, and it's not on our future offering, but we are still considering it. There are some challenges there when you do Mopa in a flatbed, as David mentioned. The focal distance is critical. There are a lot of things that need to be considered, but it is something we may possibly have in the future.
All right. How opaque is the black on the fiber on the polycarbonate? I find it really depends on the overlap and the amount of passes that you take. You can get it to where it literally blocks out light. So when you hold it up to the light, I've actually done applications to where it's like switch panels to where light is pushed through from the backside and the laser removes everything except for the lettering. So it actually allows the light to come through from the backside. So you can produce a full blackout for light with it, but you do want to make sure that you use the right settings for that. There are a chance that you can use the wrong settings or resolution where you have little streaks that kind of come through the backside when using the Fibron polycarbonate. You mentioned having both sides of the plastic masked. Will standard masking painter's tape work for this? Yes, absolutely. A lot of times the masking that comes on the polymers that I buy is durable enough to handle the cutting process. So if you're just cutting it, the plastic mask that comes with it, now if it peels or if it comes off too easily, I use just like a standard masking, like a transfer tape, or you can even use like a blue painter's tape, really any type of mask, as long as it has a surface adherence that doesn't peel away or protects the surface from the heat of the laser when cutting. If we don't have a vacuum, should we still mask the table? No, and that is the question. When you have the cutting tables that also have the vacuum underneath, I will cover the excess tables to create more of a vacuum. This one, it holds the part down, which isn't as important, but mainly it pulls the excess debris and part through that part as you're cutting it, and you'll get a cleaner part. You're going to get less flame. But if you don't have that capability, like a table, say you're running a Speedy 300 with the standard cutting table and you don't have the vacuum table, then you do not need to mask the excess table. It will not benefit you. What is the best ABS-like material that I can use to make enclosures that are more durable than acrylic? Well, I would use ABS, actually. I've actually covered ABS in the past in my plastics seminar. If you want to go back, it's on our YouTube channels. It's just under laser plastics. We cover ABS plastics. ABS is a butylstyrene, and it works a lot like it's very, very similar to the polystyrene that I just covered. Same reaction. It's less melty than the polystyrene, but you can pretty much cover the same process I just showed you on the polystyrene and do that with ABS. And it works just as well. If you do want to go back and see the process, you can go to our YouTube channel, type in seminar for plastics, and just watch that one and go to the ABS section and watch that. Trolleys Textures work great for control panels in vehicles such as ambulances, fire trucks, etc. Oh yeah, great example of where you would use it. I don't see as many applications some days, and so it's great feedback. Thank you, Jerry. All right, you're very welcome, Jerry. Thank you for attending. All right, short and sweet. I guess we answered most of them in the seminar. Perfect. Well, Andy, thank you so much for joining me today. Thank you, everyone, for joining me for this third Thursday. And stay tuned for next month, and we will we'll keep them coming out for you.
Thanks, everyone.